Hi, this is Navin, PGT Chemistry, TS Model School. In this video, I want to tell about postulates of Bohr's atomic theory. Bohr's atomic model, Niels Bohr atomic model. First, we have to know postulate. Postulate nothing but which are having only theoretical evidence. There is no practical evidence. Those are called postulates. Niels Bohr also, based on his theory, in his atomic theory, Planck quantum theory, and based on his hydrogen spectra, he given some suggestions. Those suggestions we call it now as postulates of Bohr's atomic model. Mainly, there are 7 suggestions are there. Let me discuss one by one. First one, electrons in atom, they are revolving or rotating around the nucleus in circular paths. He named those paths as orbits, shells or levels. Let me take one example. This is the nucleus having protons and neutrons. Because of that, it is having positive charge. And electrons are rotating around the nucleus in circular paths. This is the first circular path around the nucleus. First circular path around the nucleus and second circular path around the nucleus. And third circular path around the nucleus. So like this, electron is rotating around the nucleus in circular paths. This is the first point, and he given names to these circular paths. These names are orbit. It is an orbit or shell or level. And second point, each orbit is associated with a fixed amount of energy, definite amount of energy. So that's why they are called energy orbits or energy shells or energy levels. So each electron requires a specific amount of energy. It requires a minimum amount of energy to rotate in these circular paths. Let me take example. Here 2 kilocalories, just example. Here 5 kilocalories. Here 10 kilocalories. So electron requires 2 kilocalories to rotate in first circular path. If the electron having less than 2 kilocalories, it is not rotating. In the same way, second circular path having a fixed amount of energy 5 kilocalories. In the same way, third circular path 10 kilocalories. Like that, each circular path having a different amount of energy. So each electron requires a specific amount of energy to rotate in these circular paths. That's why they are called what? Energy orbits or energy shells or energy levels. And third point, the orbits he represent with a capital letters K. First circular path is representing with capital K. Second circular path is representing with capital L. And third circular path is representing with capital M, N, O, P, and so on like that. So he given capital letters to first circular path and second circular path and third circular path like that. And one more point, he given numbering also. First circular path n equals to 1, second circular path n equals to 2, third circular path n equals to 3 like that. So he given numbering also, where n is called principal quantum number. Principal quantum number represents the number of shell around the nucleus. So the number of shell around the nucleus is representing with a small n, where n is the principal quantum number. So k shell means first circular path around the nucleus n equals to 1. L shell means n equals to 2, second path, and m means n equals to 3, third circular path. That is the third point. And fourth point, as the n value increases, as the number of shell increases, the size and energy of the orbit also increases. See here, the radius of first circular path, first orbit radius is this much, means the size is this much. second the size, second shell size, and third shell size. See, this is the radius. As the n value increases, the size of the shell also increases. At the same time, the energy of the orbit also increases as the n value increases. This is the fourth point. As the n value increases, the size of the orbit also increases and the energy of the orbit also increases. Next point, fifth point. As long as the electron revolves in this circular path, it neither emits energy nor absorbs energy. That's why they are called stationary orbits, stationary shells, stationary levels. Why we are calling stationary shells or stationary levels means what? When the electron rotating in this circular path, the energy of the electron is constant. It cannot lose energy, it cannot gain energy until it rotates in this circular path. If it moves this way, like this, if it is moved like this, maybe there is a change in energy, but it cannot move like that. The energy of the electron is constant. That's why they are called what? Stationary orbits. As long as the electron revolves around the nucleus in these circular paths, it neither emits energy nor absorbs energy. That's why they are called what? Stationary orbits. Next point. But the energy of the electron changes. When the energy of the electron changes, when it is jumped from one energy level to another energy level, one energy orbit to another energy orbit. When it jumps from one energy level to another energy level, maybe there is a change in what? Energy of the electron. So due to sunlight or due to heat, when the electron absorbs energy, when it absorbs energy, it jumps from lower energy level to higher energy level. Why? Because the energy of the orbit increases. See here, example, it is having 2 kilocalories, here 5 kilocalories. So when it jumps from here to here, it must be absorbed some amount of energy. It requires 3 kilocalories. So when the electron gains 3 kilocalories, it jumps from first energy level to second energy level. So depends upon that energy gained by the electron, it jumps from different energy levels. So the energy of the electron changes when it is jumped from one energy level to another energy level. When it absorbs energy, it jumps from lower energy level to higher energy level, and by emitting the absorbing energy, again it comes back to the original energy level. So the energy of the electron decreases when it jumps from what? Higher energy level to lower energy level. So when it emits energy, it comes back from higher energy level to lower energy level. So the energy difference between two orbits or electron is given by the equation E is equals to E2 minus E1, where E is the energy of the electron, E2 is the what? Energy. Total E is the total energy. E2 is the energy of the higher orbit, energy of the lower orbit. So the difference is given by the equation E equals to NH nu, where N is the what? In the number of integers 1, 2, 3, 4 like that. So here H nu means what? Quantum, photon. So 1 H nu, either difference is either 1 H nu or 2 H nu or 3 H nu like that. So it is having 2 kilocalories, repeating 2 H nu, here 5 H nu. So the difference is how much? 3 H nu. So the energy of the electron is given by the equation E equals to NH nu. And next point, the angular momentum of an electron is quantized. So seventh point is the angular momentum. The angular momentum of an electron is quantized to h by 2 pi. So what is angular momentum? First, momentum equals to mv, mass into velocity. Momentum is equals to m into v. It is also called the mass in motion. V is velocity, m is mass. So a body is in motion. When the body is in motion, we say that it is having momentum. So momentum, if the body is moving in a straight line, that is called the linear momentum. If the body is moving in circular path, that that is called angular momentum. Angular momentum is denoted with mvr. Angular momentum, momentum is mv. So radius, r is the radius here. So when the object or when the body, the motion is in circular motion, then it is having angular momentum. When the body is in a it is moving in straight line, that is having a linear momentum. So mv is the linear momentum, mvr is the angular momentum. The angular momentum of an electron is quantized to h by 2 pi. What is quantized? Quanta, nothing but a minimum possible amount of any physical quantity. Minimum possible amount of any physical quantity is called quanta or quantized. Here angular momentum is also quantized. Means what? It is quantized to this is the minimum possible amount. How much? H by 2 pi. So mvr equals to nh by 2 pi, where n is the integer or principal quantum number. So electron in first shell, it is having how much value? H by 2 pi, 1h by 2 pi. mvr equals to angular momentum is how much? 1h by 2 pi. The electron which is in second shell, it is having how much angular momentum? 2h by 2 pi. See, 3h by 2 pi. Third shell, the electron angular momentum is 3h by 2 pi. So what is the minimum value? Minimum possibility value here? H by 2 pi is the minimum possibility value. So if there is these are the discrete values. Quanta is nothing but discrete values also. So here discrete values are there. That's why the angular momentum of an electron is quantized, and the value is mvr equals to nh by 2 pi, where m is the mass of the electron, v is the velocity of the electron, r is the radius of the orbit, n is the principal quantum number, h is the Planck constant, 2 is the constant, and pi value is 22/7. For example, a physical quantity having 2x, the values, discrete values are like this: 2x, and one is having 4x, and one is having 6x. Like these values are there, then we say that that property is quantized. Why? Because the minimum possibility value is here 2x. So the difference is 2x. A fixed, a specific amount is there. That's why we say that these values are whatever it is, the physical quantity is quantized. Here also the difference is h by 2 pi. So h by 2 pi, h by 2 pi, and so on. That's why the angular momentum of an electron is quantized to h by 2 pi, and the value is nh by 2 pi. mvr equals to nh by 2 pi. These are the 7 postulates of Bohr's atomic model or Niels Bohr atomic theory. Thank you.